In JEE Main, the problem on system of linear equation is not uncommon. There are multiple PYQs based on system of linear equation having unique solution, no solution, or infinite number of solution. This is one of those problems. S is set of all the real values of lambda for which this system of linear equations. You can see that first equation lambda x plus y plus z equals to 1. Second equation x plus lambda y plus z equals to 1. And the third equation x plus y plus lambda z equals to 1 is inconsistent, right? This system of linear equation is inconsistent. Lambda is set of all those values for which this will be inconsistent. S is set of all those values for which this will be inconsistent. Then we have to find this one summation lambda belonging to S modulus of lambda square plus mod lambda. Now, the meaning of this word inconsistent is that this system of linear equation will have no solution, right? Inconsistent simply means that it will have no solution, right? Either it will have, consistent means that it will have solution, either unique solution or infinite number of solution. And inconsistent means that there is no solution for this system of linear equation. So the condition for no solution is that determinant of coefficient matrix, this one is 0, and then any one of these three, right, delta 1, delta 2 or delta 3, at least any one of these three, this is non-zero, right? That means delta is 0, delta 1 is non-zero, or delta 2 is non-zero, or delta 3 is non-zero, then it will have no solution, right? So the necessary condition for inconsistency is that delta must be 0. So first, let us try to find the values of lambda from there, right? And then we'll see whether, for those values of lambda, what should be the values of delta 1, delta 2, and delta 3. So here, for inconsistent or for no solution, the condition is delta is 0. If I equate delta to 0, that is, if I equate the determinant of coefficient matrix to 0, then for determinant of coefficient matrix, the first row will be lambda 1, 1. The second row is 1, lambda 1. These are nothing but coefficient of x, y, z. Third row, this will be 1, 1, lambda. Right, first row is coefficient of xyz in first equation. Similarly, second row, coefficient of xyz in second equation, and so on. Now, if the system of linear equation is inconsistent, this must be 0. Remember, this is necessary but not sufficient condition, because delta should be 0 and then any one of remaining three, delta 1, delta 2 or delta 3, that should be non-zero. So here if I expand this determinant along the first row, let us say, so then we'll get lambda into lambda square minus 1, and then minus 1 into lambda minus 1, right? Minus 1 into lambda minus 1, and then plus 1 into 1 minus lambda, and this must be 0. Lambda minus 1 you can take common from all of these. So from first term you will get lambda into lambda plus 1, and from here you will get minus 1, another minus 1, so that is minus 2. So we have lambda minus 1, and then we have lambda square plus lambda minus 2, this equals to 0. So from here we are getting these three values of lambda, 1, 1 and minus 2, right? You will get 1 from here, and the roots of this quadratic, that will be 1 and minus 2. So these are the three values of lambda that we are getting, right? Now, if you take lambda as 1, right, if I take lambda as 1, then our system of linear equation, this will become x plus y plus z equals to 1. Second equation also x plus y plus z equals to 1. And the third equation is same, x plus y plus z equals to 1. Now here we don't have to calculate delta 1 and delta 2 and delta 3. Directly you can see that this system of linear equation will have infinitely many solutions, right? Because all the three equations, they are identical, right? Take any value of xyz which satisfies equation 1, then it will also satisfy equation 2 and 3, right? So for lambda equals to 1, we are not going to get no solution, right? For lambda equals to 1, the system of linear equation will be consistent and it will have infinitely many solutions, because any xyz satisfying equation 1 will also satisfy 2 and 3, because all the three equations are identical, right? So lambda equals to 1, this will give us infinitely many solution. So the only other value that we are getting is minus 2, right? and none of the options are 0. So therefore, only value of lambda for which it will be inconsistent is -2. Right? If you want to be more sure, then you can write the system of linear equation for lambda equals to -2. If lambda is -2, then the first equation was lambda into x, right? First equation lambda into x, so -2x plus y plus z, this equals to 1. Second equation x minus 2y plus z equals to 1. And in third equation we had 1 1 lambda, so that means x plus y minus 2z equals to 1. Now here you can calculate delta 1 and you will find that delta 1 will be non-zero. But there is no need to calculate this one also, because for 1 we have found that uh, for 1 the system of linear equation is consistent, it will have infinitely many solutions. So only other value of lambda that is left is -2. And if this will also not satisfy that condition, then sum of this value will be 0. There is no option 0 here. So that means -2 must, for -2, the system of linear equation must be inconsistent. And if you want to be 100% sure, then you can obviously write the system of linear equation and calculate delta 1, right? So the only value of lambda for which it will be inconsistent is -2. Now we need this sum, summation lambda square plus lambda, and lambda belongs to S. There is only one element in set S. That element is -2. So -2 square, that will be 4, plus modulus of -2, that is 2. So 4 plus 2, that is 6. So that should be the correct answer for this problem. Right, so in this problem, for no solution, or if the system of linear equation is inconsistent, then delta will be 0, and any one of these three, at least any one of these three, that will be non-zero. By equating the delta to 0, we got three values of lambda, 1, 1 and -2. When lambda is 1, we are getting infinitely many solutions, and when lambda is -2, then we are getting no solution. So therefore, the only value of lambda in this set S, that will be -2, and for that this sum will be 6. So the correct answer for this problem is option D.